In these next steps, we're going to try and link the concepts needing to be taught from 3 different assessments: grouping in place value, basic facts, and addition and subtraction, to show how the areas are interconnected. And by working on the ideas together, our pupils will hopefully be able to see the links more clearly and be able to apply their knowledge more effectively. Here is the assessment overview for the pupil. We're going to explore the gaps in the grouping in place value and the basic facts, and look at how these impact on the addition and subtraction. The 3 earliest gaps in knowledge, strategy, and understanding across this pupil's grouping in place value, basic facts, and addition and subtraction assessments were supervising patterns, particularly irregular patterns to 10. In basic facts, the difficulties were related to the recall of addition and subtraction facts to and within 10. There were also difficulties highlighted with missing number problems, including missing addend problems, missing subtrahend problems, and missing minuend problems. Solving problems that involve regrouping or bridging through a multiple of 10, for example, the question in Task 5 of the addition and subtraction assessment that involves solving 37 take away 9. It is no surprise that the foundations for the skills involved in the basic fact recall stem from the grouping in place value gaps, and the skills involved in the highlighted difficulty with the subtraction problem require the basic fact knowledge that is missing. Therefore, in order to improve the subtraction difficulty, the other 2 areas need to be addressed and then linked to this. Let's tackle the grouping in place value difficulty first. This could be done in a number of ways, and it would be useful for the pupil to have multiple representations of this, so they are more likely to generalize their understanding and apply their learning. You can see the areas we are trying to target in the Highland numeracy progression in the grouping in place value section in first 1 star. In the 2017 update, this is on page 25. This could be introduced, for example, by setting pupils a challenge of finding all the ways to make a target number within 10, for example 7, and asking them to use 2 colours to make this number. You could provide a structure for this, for example a tens frame, or leave it more open-ended and see what they come up with. For pupils that won't find this particularly challenging, you could challenge them to think about how they know when they've definitely come up with all the different combinations, or ask them questions to explore this problem further. For example, what if you used 3 different colours? Are there a greater number of combinations or fewer? What about 4 different colours? Are there a greater number of combinations now or fewer? As you increase the number of colours, what do you notice happening? At this stage, we're just getting pupils to explore patterns and relationships and different ways of grouping items, so they see that numbers can be broken up in different ways. This could all be done in a variety of different ways. This could then be linked to the early stages of our basic fact objective of being able to link the groupings with recalling these groupings instantly and relating them to addition and subtraction facts. You can see the relevant basic facts highlighted here in the Highland numeracy progression at first 1 star and first 2 star. You might ask the pupils to look at their groupings and record the number sentences that match their pattern. What would this look like as an addition problem? Is there another way to write this? This begins to explore the idea of commutativity. What patterns and relationships do you notice? What would this look like as a subtraction problem? Is there another way to solve this as a subtraction problem, and can you show me? What do you notice about the similarities and differences between the addition problems and the subtraction problems? Pupils might begin to notice that for the addition problem, the 2 addends were just switched, but the total was the same. Whereas for the subtraction problems, the minuend stayed the same in both cases, but the subtrahend and the difference switched. Pupils could be extended further by experimenting with what happens if you switch the minuend and the subtrahend. Pupils will see through trying it that it doesn't result in the same difference. Some may see that this is because if you have 4 physical objects and you try to take 7, it's not possible. There aren't enough things there. For other pupils who may have some understanding of negative numbers, they may realize that you could, in some contexts, keep subtracting the other 3, and that this would result in the answer -3. 4 take away 7 equals -3. Either way, your goal is to help them to look at the relationships between the numbers and start to appreciate that while addition is commutative, it doesn't matter which way around the addends are, subtraction is not. It's also important to vary the position of the equals sign, so pupils see it represented on both the right-hand side and the left-hand side. Many pupils think the equals sign just means the answer to the problem, rather than being a relational symbol that represents equivalence. That is, whatever is on one side of the equals sign is of equal value to the other side. Really understanding the equal sign may mean that pupils have fewer difficulties when they're introduced to algebra later on. These different groupings and their related addition and subtraction number sentences could be reinforced and the screening phase of the teaching model introduced through something like dot talks, where pupils see a dot pattern for a few seconds and then it's hidden. Pupils then have to say how many dots they think were there and how they saw them. Did you see 2 groups of 2 and a group of 3 like this? Or perhaps like this? Or maybe a group of 5 like the dice pattern and 2 more on the outside? Or perhaps a 4 in the shape of a square and another 3 horizontally through the middle? For a video example of this, take a look at this video from Joe Bowler on the UCubed website. These dot card number talks have the benefit of pupils seeing the dots in a variety of ways, including irregular patterns. Different pupils may see them grouped in different ways, and the initial presentation is just brief, so pupils are in that screening phase where they're having to visualize what's there. You get the added bonus of pupils having to use lots of mathematical language to describe their patterns. To get to grips further with the missing number problems, attaching some sort of context to it can also help. For example, a group of children were on a camping trip. They were all playing a game in the tent. After a while, 4 of the children decided to leave to play their own game. There were 6 children left in the tent. How many children were there to begin with? The image here could be easily recreated in the classroom with some basic materials, and when the 4 pupils come out of the tent, either real pupils or just miniature figures, the pupils could peek inside the tent or lift the cover off, depending on how it's been built, to see the 6 inside if they need to. This context helps make it much clearer that to work out the total number, you need to do 4 add 6, as opposed to 6 take away 4, which is what lots of pupils would do if they just saw this problem written down. The written recording for this could be modelled within the context of the problem. The materials could then be replaced with slightly more abstract versions to help pupils begin to generalise their understanding. For example, the children could be replaced with counters, and the tent replaced with a piece of card to screen the counters. There were a group of children in a tent, 4 children left. There were 6 children left in the tent. How many children were in the group? A similar problem could be posed, either with or without a context, depending on how the pupils are progressing. This can also be linked to a visual, such as a bar model, to help make sense of it. Let's go back to the tent problem momentarily. A group of children were on a camping trip. This is the whole, and we don't know how many children there were. 4 of the children decided to leave the game, so we're removing 4 from this original unknown amount. There were 6 children left. Now I can see that to figure out the problem, I need to add 4 and 6. We don't want pupils to rely on contexts, materials, and visual supports forever, so our teaching needs to link these things and have an exit strategy, so they can gradually move away from them until they're able to solve these problems in both real-life contexts and more abstract contexts, such as this bare number problem, something, take away 4 equals 6. How long this takes pupils and how long you spend on each phase of the teaching model will vary from pupil to pupil. Again, to get depth in understanding rather than just superficial understanding, problems involving missing numbers could be explored. But now there are 2 or more numbers on both sides of the equal sign. For example, 4 add 3 equals something add 5. This would again be done through concrete materials and visuals first, and later through more abstract examples like bare numbers. You may be interested to know that a similar question to this was posed in the Trends in International Mathematics and Science Study, 2011 Grade 4 Maths Assessment items. This is roughly equivalent to P6 pupils taking this assessment. These assessments are carried out internationally approximately every 4 years. The question can be seen here. So remember, this test was taken by pupils who are approximately P6. Have a guess at what the international average was in terms of the percentage of pupils getting the correct answer to this problem. The answer is 39%. Was this better or worse than you thought? Unfortunately, there is no Scottish data for this, but for comparison, the average for England was 29%, the United States were 47%, and the highest scores were Hong Kong at 88%, with Singapore just below them at 85%. Hopefully this highlights that while we might be keen to just say that our kids have learnt certain concepts because they can recite a set of basic facts, do they really understand them? Can they use them in a variety of different ways and contexts, and can they apply them? When we are looking to differentiate, do we really need to race on to larger and larger numbers, or would we in fact be better keeping more pupils working on a number range that is more age appropriate, but exploring the concepts in more depth, such as problems like the one here? If they truly understand the concepts, and pupils are supported to make connections between the different areas, moving on to larger numbers should then be much simpler. So, pupils now have a better understanding of the different ways you can group items within 10. They've linked this to the written recording for this, and they're developing an understanding of the relationships between these numbers, including making sense of the commutative property, the relationships between addition and subtraction, and that one is the inverse of the other, as well as missing number problems. These ideas related to relationships can be seen in the Highland numeracy progression in the addition and subtraction section at first 1 star. Independent activities can be set up so that pupils are then working on moving these basic facts from something they need to use a strategy to work out, such as counting on or reliance on visuals such as finger patterns or other visual groupings, to just knowing the facts. Games that you may have heard mentioned in other videos within the assessment training that would be appropriate here include Dotty2, Snap It, and Strike It Out. Remember to keep in mind the basic facts that you are trying to develop and ensure the pupils are clear on this. While they're working on these, even if they haven't yet got instant recall of them, the pupils can start to link this with how they can apply these facts to solving addition and subtraction problems. In classes where grouping, basic facts, and addition and subtraction are all taught in blocks independent of one another, pupils may find it harder to see the links between these, and while they may end up having instant recall of their facts, you may find that they don't go on to apply them in order to solve addition and subtraction problems, for example. We'll now revisit the area that this pupil was having difficulty with, bridging through a multiple of 10 to solve subtraction problems. This happens to be an incredibly common difficulty and is another type of problem that frequently arises across a broad range of pupils. It can be found in the addition and subtraction section of the Highland numeracy progression in first 2 star and again at first 3 star. Although the problem in the addition and subtraction assessment was 37 take away 9, initially it might be beneficial to take it down to a lower number range to begin with, just to develop familiarity and understanding. You may be wondering why, if she's already been assessed at first 3 star, we're exploring concepts at the first 2 star and first 3 star level. As has been emphasised all the way through this video, while pupils can often get so far with certain knowledge and information, you sometimes need to go back a few steps to get deeper understanding, so that pupils can then make more sense of the problems. This should make it easier to then move on to larger numbers later, so pupils may end up progressing more rapidly in the long run. When they start to learn a range of different strategies, all that foundational understanding will stand them in good stead, and with better number sense, they may be more likely to look critically at the numbers in a problem and choose the most appropriate strategy, which, along with a broader number range, is what we're trying to develop at second 2 star. It should also be noted that an additional piece of knowledge is also required for this strategy. Knowing how to subtract to a multiple of 10, For example, knowing that 12 take away 2 equals 10, or 37 take away 7 equals 30. If pupils don't know this yet, then again, this would need to be worked on prior to this, in a similar way to what we've already described. We'll explore this here through TIMSS frames, but it could and should be done with a range of other materials and connected to a range of story-type contexts. Let's start with the problem 12 take away 7. We could discuss initially whether anyone just knows the answer to the question and whether it's easy to take off the 7 all in one go. For pupils at a similar stage to this pupil, the answer to both these questions will be no. But it is useful to highlight this initially so pupils see the relevance of the strategy. We'll set up the 12 first and talk about how we could build this, for example 10 and 2. With the materials visible, we can then discuss with the pupils what might be an easier amount to take away first of all. Because of the way the items are grouped, it becomes more obvious that you could just take the 2 away. It is crucial to help pupils make the links between those basic facts they've been working on and this problem by discussing what would be left to take away from 7 if they've already taken away 2. Now they're starting to see the importance of just knowing that 7 is made up of 2 and 5. When the pupil removes this 5 from the remaining 10, again, link this to facts that they know. Some pupils might say they know this because of their number bonds, 10 take away 5 equals 5, and others might make the link to doubles and halves to 10. For example, I know that half of 10 is 5, which is the same as 10 take away 5 equals 5. The pupils can then see the answer to 12 take away 7 is 5. When ready, the pupils could connect what they are doing on materials to a visual. This could be a part-whole model, such as this one, sometimes known as a cherry model. Bar models can also be very effective. Number lines, either structured or empty, are also helpful. Initially, the adult could model written recording using the number line as the pupils demonstrate the strategy on the materials. There's then a shift so the pupils are doing the recording rather than the adult. You can see an example here with the problem 14 minus 6, where both a cherry model and an empty number line have been used. To move the pupils away from the materials, the screening or imaging phase could then be introduced. Lay something over the top of the materials so they're no longer visible, which encourages the pupils to visualize what's there, and ask them to talk through how they're going to solve the problem. If needed, the materials can be revealed to check. Finally, the pupils should be able to solve these problems mentally without needing to write anything down. You could then push the number range up slightly, but still just having a 2-digit take away a 1-digit, for example 25 take away 8, or 34 take away 7. The process would be the same as the above, working with materials first, using these alongside a visual, screening them, and finally the pupils just being able to solve this mentally. The related problem that the pupil had difficulty with in the addition and subtraction assessment, 53 take away 26, requires other knowledge in order to be able to solve the problem efficiently. But interestingly, although this pupil has already demonstrated this knowledge, such as incrementing and decrementing in tens off the decade, they are not yet applying this knowledge effectively to addition and subtraction problems, and so perhaps don't see how it relates or why it would be important. Through the use of the teaching model, questioning, and discussion, the pupil can make these links. The pupil can already subtract a 2-digit multiple of 10 from another 2-digit multiple of 10, for example, 50 take away 20, and so on, but now needs to join this up with their decrementing in tens skills. With the other skills that the pupil now has, making this leap and applying it to something like 53 minus 26 should be much easier, but I would still return to the teaching model. A brief example of how this might look for the problem 63 minus 28 might be setting up the tens on the tens frames, discussing what could be taken away first. This could be either the tens or the ones. Let's go with the ones, as it more closely matches what we were doing previously. So, take away 3 to get 60, and then another 5 to get 55. This part now requires application of number bonds to 10, Again, this needs time to be explored in its own right to ensure pupils understand this and have made the connections. I know I've taken away 8 now, so have 20 more to subtract. 55 take away 20 is 35, so 63 minus 28 equals 35. It is good practice for pupils to get into the habit of estimating their answers, to get a sense of whether their final answer is right or wrong. Pupils should also be encouraged to check their final answers. For example, can you use a different strategy to check whether you were right? Or perhaps use the inverse. For the problem we just solved, we'd need to use addition to check we'd completed our calculation correctly. Hopefully, as well as clearly identifying next steps for this pupil, this has also helped to clearly show the importance of not teaching these skills in isolation, and highlights how crucial the interconnections are between grouping in place value, basic facts, and addition and subtraction, among other things. Going deeper with your questioning within a particular concept so pupils really understand it. The importance of the underlying knowledge required to use a particular strategy. And the importance of using the teaching model each time a new concept is introduced or taken to the next level. There are a variety of other areas that were also identified in these assessments, and next steps for these should also be considered, but are beyond the scope of this video for now.